Alright then, we are on. We are live. So in the description there is actually the link to the past paper that I'm doing in the description. Right then, so what I'm going to be doing is I just need to bring up my tablet for you actually, just so I can have that ready. What I will be doing now is I will be going through each question, attempt to sort of answer them, but although on the questions where I have to, where I ask you to draw a diagram, then I will do that. Right, so we're going to do the Skype thing again. Welcome. And I'm already doing the video. So if I just...
Share your screen again?
Yep, you can should be able to see it, yep. Good.
Yep, perfect.
So, I should actually get the Markscheme up as well. I've completely forgot about Markscheme.
That'd probably be good.
Yeah, I was playing some Just Cause 2 just a while
I was
ago.
watching some law-abiding citizen video clips.
So January 2011.
January 2011, got it. Perfect.
Okay, let's bring that down again. And now let's actually show the screen. There we go. Ooh, need to bring up my view to tablet.
Okay. I'm going to quickly put something on to eat. I'll be back in a bit.
Right.
Just continue the questions. The first couple are just basic ones. Yeah, mate.
Right. Alright, so I'm actually just going to set this up actually. Let's go new tab. There we go, map tabs loaded. So it should present now. There we go. You should be able to see that. I'm just going to plonk that up there. And have the Markscheme here. So the first question, in complex, in the context of printing, describe spooling and why it's used. So spooling, that's the disk thrashing. You could involve that maybe. So the transmission of data, it uses buffers. So you'll probably mention something about buffers as well. So if I just load in. So I would mention something about buffers. And explain, so describe spooling and explain why it's used. So I know so spooling, I completely forgot really what it is, so, wow, that's a lot of stuff. Is an output, let's zoom in a bit, so you can see it a lot better. So is an output data to disk drive for printing at another time, to allow sharing. Job references are stored in a queue, avoids delays, as printers are relatively slow. Jobs can be prioritized as well. So I'll probably remember the outputs data to disk drive for printing at another time. It allows sharing on a network. It avoids delays. The printer is relatively slow. Yeah, so the next one, so 1B. An operating system may use segmentation and paging when managing memory. State two ways in which segmentation and paging are similar. They both are ways of storing data. both ways of storing data. I don't know what else. Yeah, so not storing data, whereas a partitioning memory. Allows programs to run despite insufficient memory used for virtual machines. Oh yeah, I should have mentioned something about that. Segmentation and pagings are stored on backend store. Backend store comes in again. Segments and pages are assigned to memory when needed. So one difference between segmentation and paging, is it segmentation? No, paging is segmentation is a fixed size. I believe fixed size for the data. Segments are different sizes, but pages are the fixed. Segments are complete sections of programs, but pages are made to fit sections of memory. Memory segments are logical, pages are physical. Explain one problem, so you did actually see that bit before. The problem is that may occur is disk thrashing, and then you'll explain it a bit more. So disk thrashing is when data is being swapped between the virtual memory and physical memory. So from the processor to the hard drive, which ties up the processor. So disk thrashing is when the processor spends more time transferring the pieces of data. So disk thrashing, more time spent swapping the pages than processing, the computer may hang. I didn't mention anything about segmentation. Well, pages are like within both. One stage of compilation is syntax analysis. Give the correct name for each of the other two stages. Lexical analysis and code generation. Yep, lexical analysis and code generation. 8. Describe what happens during syntax analysis. So that is syntax is, I'm thinking back to F452, I believe, where it talks about the different types of error checking. So syntax, it checks to see if the code follows the rules of the programming language. It also does check that every if statement has a matching end if. And then it passes the code on to code generation. Yeah, I should have mentioned accepts output from lexical analysis. Right. Are you back now? So accepts output from lexical analysis. Statements or tokens are checked against the rules of the language. Diagnostics may be given. If no errors, then code is passed on to code generation. Further detail is added to the symbol table, for example, data type, scope, and address. Some compilers produce intermediate code. Explain the term intermediate code and its use. I know it can be used on virtual machines. Intermediate code is code that is half translated from the source code to the object code. it can improves portability. So let's see. So it simplified code, so partially translated. So I got that, which can run on any computer or virtual machine. Improves portability. Uses an interpreter. That's what you need to include. Sections of a program can be written in different languages. Runs more slowly than executable code, and that's it. Are you back now?
Hello.
Hello.
Hey, I went upstairs and there was a heater's on and a apple pie. Oh yes.
Right.
Okay, so.
We're actually on question 3.
Oh wow, got pretty far.
But do you want to go back to the previous question? Can you remember, explain the term immediate code and its use?
Wait, let me just put my meal down. Which one do you want?
Explain the term intermediate code and its use.
Intermediate?
Yeah, this was the question that I've already given an answer to, but it's just to test you.
Why do we need to do that?
I don't know.
This is not a quiz. Okay,
This is over there.
intermediate code. Okay. So, intermediate code is simple code. Oh god, no, I need to put that back in. It's that simple code, which it uses an interpreter
Yes.
and explain the term and its use. Its use, it can be run on any machine, can't it? Like, it improves, so it has portability.
Yeah. So it's 3 marks and you did 3 statements. So on the mark scheme it says simplified code or partially translated code.
By the way, I do have the mark scheme in front of me, I was just reading off. Anyway, let's move on.
Let's move on. So question 3, explain, so in classic
I'm
von
gonna be
Neumann...
eating, so I'll leave you to answer.
Term register, so it's a place in the processor, is located in the processor, and it handles data. So
it stores information and bits.
Yeah. How many of them? Oh, right, never mind. That's the next question. I was about to say, can you name any of the special registers? Be careful not to reveal the next answer. There we go. So, a location in the processor used for a particular purpose. Temporary stores data. Explained example of contents held by named register. So, give an example, pretty much.
Yeah. Who, me?
No, it's just what it says in the mark scheme for the explained term register.
Yeah.
And it's only 2 marks, but that can be the difference between grades.
Yeah. Indeed.
Give the correct name for 2 of the special registers used. Do not use abbreviations. Special registers.
That's pretty easy.
Yeah, so
that's the F451.
Yeah, that's the MDR, MAR, but do not use abbreviations. Yeah, I was going to say, it's like, why am I doing abbreviations? So memory address register, memory data register.
Yeah.
You could also say the program counter.
Yeah.
And then the current instruction register. I don't think they would accept accumulator though.
They might. I think there's index register and
interrupt register.
Yeah, interrupt register.
Let's have a look. So a program counter, memory address register, memory data register, current instruction register.
I never realised how many of these marks are like little marks.
Yeah. Then index register, interrupt register. Oh, they do accept accumulator.
Good for you then, because you mentioned that twice.
I said they probably won't accept accumulator before though, so...
Last paper you were like, accumulator, so it seems like you're a lucky one.
Yeah.
Yeah, I know.
Yeah, that was about intermediate addressing. I was talking about that. advantage and disadvantage of parallel processor architecture compared with von Neumann. Multiple processors can be done at once. Von Neumann is a single one.
Single control unit.
Yes.
Do you have any more? It's 5 marks.
So advantage of
Parallel processing is faster, I think.
Yeah, faster. It's due to the explain the advantages. So multiple advantages and then disadvantage. Then disadvantage for von Neumann is that it's slower since it only has a single register thing. So let's have a look. Advantages: allows faster processing. More than one instruction is processed at the same time. Different processors can handle different tasks. Disadvantages, though, is operating system is more complex, so that's for parallel, because more data and so. So more complex to ensure synchronization. Programs have to be written in a suitable format, not language, suitable format. Program is more difficult to test, write, and debug.
It's all linked into it's harder to do certain things, basically.
Yeah. The real binary number may be represented in floating point binary notation. 5 bits for mantissa, 3 bits for exponent. Both in 2's complementary binary.
Oh yeah, I've done this question, I remember this.
By converting each of the P, Q, and R to generate, show which represents a different value. Well, I know it's R that represents a different value.
How?
Look at it is a negative exponent. It starts with a 1 in the exponent.
Yeah, well done. Right, but you need to.
Yeah, you need to
solve them.
Yeah, because within the. I'm not going to solve it. I'll do it a bit. Should I solve it or might as well solve it?
You might as well practice. I remember what the answer is, I know.
Oh, didn't mean to rotate it.
For 2 of them, you'll get 1, and then for the third
Yeah,
one,
and I
you'll
know
get
that
3.
it is dependent on actually the. Because I've actually seen this question when I did the questions for data representation.
Yeah.
So we've got 0, 1, 0, 0, 0, 1, 0. So that's minus 4.
Back in just a moment. I'm going to get another. So I'm going to get seconds if they're available.
Right. 8. Yeah, so it's. And that is. So 1 over 4 times 2 to the power of 2. That's 1. Is that really 1? Well, I think I may have done something wrong. No, it is the value 1. So that P. Oh, I should have actually labelled that. So that is P. Then, so you'll have to do P, then Q. I keep forgetting to. So P, Q. You've got to solve both of those. Let's scroll down.
Hello?
Hello.
Okay, what question? What part you on?
Just doing Q.
Okay.
16. 1, 2, 3, 4, 5.
Oh,
Yep.
it's really spicy, this. Do you like spicy food?
Don't mind it. I just had some prawns for tea.
Yeah. Oh, it's really spicy.
So 1 over 16.
It's got jalapenos. I can't even pronounce them.
Wait,
Jalapenos. Sorry, yeah, we're doing a live stream. Okay, sorry.
Yeah, I accidentally got a bit distracted, so I kind of just did R instead. Let's show R. That's what happens when I. It's like, have you ever actually like done this where you've looked at a question,
Yeah.
you've answered it, you've done it,
Yeah.
all written it down.
Yeah.
You go to copy down the next question,
Yeah.
but your eyes go up a bit more, so
Yeah.
you accidentally copy that question.
Yeah. And a lot, especially with what do you mean you copy like a brand new question or just a different part of the question?
Like the next. So you've done. So I've done P,
Yeah.
but I look down to R instead.
Yeah. That happens to me a lot, especially with maths, because you have like two simultaneous equations, like which I'm sure. Do you know what simultaneous equations are?
Yeah, I
Yeah,
did
yeah.
maths.
So you should
So.
know from GCSE. Yeah, no, you did it. You didn't do it like AS, did you? Though?
No.
Yeah, so you know it from GCSE. So like, it's very easy with that because you have to put them above each other, like to accidentally copy something down.
Yeah.
So I remember when I was doing my AS exam this year, there was in fact a simultaneous equation one. The time limit is quite constrained, like it's quite tight. And I remember I got through a question, and I'd spent a good 10 minutes on it, and I produced values, and they were completely wrong. They were like 11 over 18, which you would not get in a C1 paper because it's non-calculator. It was very unlikely. So I remember I went through the question, and I discovered that the question, I copied down the question, and the question had a plus in it where I'd put a minus. So I had literally, and it was a time exam. I spent 10 minutes on it, and that's like a lot of time of the exam. And I'd like cross out a full page and do it again. Oh, God, it's terrifying. Anyway, sorry.
Yeah, so state the format. Next, I'm just going to skip to the next question because I can't really be bothered. And I already know that R's different because it has a minus. It starts with -4 in the exponent. But so let's see. It doesn't actually say.
You got the values right anyway.
Yeah.
You got one for the first one, didn't you? P, and then one for R. Then that.
Yeah.
That one.
And sometimes they are strict by saying you have to answer P and Q to make sure it's dependent.
Yeah. Okay.
State the format of the mantissa of an normalized floating point binary number.
That'll just be 1, 0, or 0, 1.
Yeah, and what is 104?
That's negative. And then 0, 1 is positive.
Yep.
I don't think you need to state that though.
Yeah, you just need to say it starts with 0, 1 or 1,
Yeah.
0. They're not that strict.
Ooh, we've got a normalized version now. This is fun.
Ooh, yes. Fun.
You rarely see these, to be honest. I remember I was going through with my teacher and I asked her to do an example for me. And I couldn't find one because they're quite rare.
Yeah. Normalize. Yeah, so you've got to move the decimal point. So let's just write this out. So 0, 0, 0, 1, 0, 0, 1. So the dot starts probably about there, doesn't it? Or is it there?
No, it'd be there. Obviously, you need to. So you work out the exponent.
Yeah, so it's going to be minus something in it.
Yeah, but you work out the exponent first.
Well, you've got to work it out, so you've got to go 1. Oh, good.
No, you do that later. Work out the exponent first, the value of the exponent.
Oh, yeah. And then you've got to...
And then you do the mantissa and then add it to the exponent.
Yeah, so that is 3.
Okay. So then
It goes...
Then you work out how many... Yeah, so that's 2. No, it's just 2.
Is it? Oh, yeah, 0,
Q
1.
0, 1.
Yeah.
So then it's 3 minus 2.
Yeah, I'm just going to change the colour.
Good. So it'll be 3 minus 2.
Yeah, I'm confused. Oh, good. Alright, so...
3 minus 2.
3 minus 2.
Yeah. Oh, yeah, for anyone who doesn't understand, it's because we moved back 2 from the mantissa.
Yeah, so 2... So they wanting it to write down the next number, is it? So give the normalized version, so it'd be 0, 1, 0.
Then add the zeros you replaced at the end, so it'd be 0, 0. And then the exponent.
Yeah, so 0,
So,
1, 0.
No, because it's 3 minus 2, so that's 1.
Alright.
Yeah. That should be correct.
Yep.
Yeah. Perfect.
It's like a sauna in my room.
Should fill my mouth. Oh god. So what? It's curry. It's not even curry, it's enchiladas, I think it's called.
Consider the normalized floating point number in format describe. Explain why. This is because it's the highest number.
Yeah. It's the highest number that can be represented in
The
binary.
highest positive number.
Yep, that can be.
You've
Yeah,
got-
yeah.
Yeah,
So
so
how would you do negative? Would you just choose complement and invert it? Oh
I-
yeah, you just do 1 0 0 0 0 1 0 0.
yeah, I think
Yeah.
so. You just
Yeah.
so just invert that to get the negative.
Yeah.
So the highest possible positive number.
That can be represented in this format.
Yeah. As the mantissa and exponent have their largest values.
Yep. Mm-hmm.
Ooh. January to floating point.
More fun.
So we've got
I think you're
positive.
doing pretty well, man. You're doing pretty good.
Yeah. Well, my teacher did that video.
So what are you on currently? What do you need to get like let's say a C?
Well, I think my target is a C though.
Yeah. What do you know what you need to do in the test?
What do you
I know
mean?
that. Do you know what you need to get a C? Because I know that if I don't even arrive at the test, I'll get a D. I'm on a D at the moment.
Don't you have to get like 75 or so to get a C?
In what? Well, last time we was up 120,
Yeah,
and last year 87 was an A. 87 divided by 120. So that was I've messed up one. That was 72% was an A last year.
I'm just gonna quickly get the grade boundaries for this year. So grade boundaries OCR
This year.
Jan 2011. Yeah, during 2011.
This year, yeah.
Alright,
Yeah,
so
at the beginning, these exam the grade boundaries were very high.
yeah, and then they lowered them. Yeah, I was looking at F451.
Yeah.
The grade boundaries, it went down by 1 each time. Then a big difference. Then it went back up by 1.
Yeah.
Then it went back down a bit.
Yeah, because previously, like, if you look at the earlier papers, they were mainly just like regurgitation, whereas now you have to actually understand concepts and stuff and such.
Right.
Yes.
For this paper, in 2011, a C was 75.
Wow.
A A was 95.
Wow. Geez, fair enough.
A D 65. So.
What about for the 2010? Oh yeah, you got a D on it.
Yeah.
Well, we're doing pretty good so far, but I don't think we've really lost any marks so far.
Yeah. So we've got two point. So positive 2.5.
Do you know how to attack this question? Like the way you structure it the correct way.
1632. Wait, is it how many? Is it same format? So how big? Where's the thing? So.
What are you doing?
5-bit for mantissa, 3-bit for exponent.
Yeah.
I just wanted to do that.
So yeah, write out the
1, 2.
the binary value first. Write it out.
Yeah, so 0. Make it easier, kind of see.
Yeah.
0, 0, 0, 1, 0. Then there's the point, and it's the half, quarter, eighth, It's just 8 finite. It's 3 bits for the exponent. So 25. So 0.
Crap. I spilled my food on my shirt.
So then you just got to normalize that.
Yeah.
So
Wait, it is normalized.
No, it's not. Because the dot's there.
Yeah. Okay.
So you need to move 1. And it's positive, so 0.1. So 1, 0, 1, 0. Yes.
Why are you moving the dot from now?
Because you need to normalize it.
If anything, the dot would start from 16 between 8.
I've always done it like this.
But you don't start the dot between the mantissa and the exponent.
No, this is just like putting that out in the binaries thing.
Yeah, no, just do it. Just do what you want. I'll see what you're doing.
Right, so then your new exponent, so minus 4 to 1, it moves 2 spaces, so 0, 1, 0. So finish things that. Let's see if that is. Ooh, I just realised I'm not really showing it that much. There we go. What question next? 4D. So answer. Yeah, I've got the same I've got the correct answer. So what are you saying that it's wrong by? Oh, wait, what? Impure binary.
Yeah.
Oh, so it goes. So the dot is meant to be there, and it goes backwards.
Yes, what I said. No.
Yeah. Oh, I've been starting in the wrong place.
Between 16 and 8, I said it makes no sense to be between
It's probably just because that's the way it's.
We still got the
always
right
got it.
answer,
Yeah,
it doesn't
so
really matter.
yeah,
But,
I need to remember it starts 0, like at the
it starts between the first 2 bits of the mantissa.
And then the dot is removed because the binary assumes it's there.
Yeah.
Right.
I really stained my shirt. It's a good shirt as well.
The tree is is a dynamic data structure. State the meaning of the term dynamic when applied to a data structure.
Okay, that the size changes during processing. It's not fixed, basically.
Yes. New page.
In reverse of static, which is fixed.
Size changes as data is added or removed. Size is not fixed. So you get away with just saying size is not fixed.
Yeah. I thought it had to do with during processing, but okay.
No, I don't. It's just when data is added or removed.
Keep changing their mind. That was in a previous.
Well, it was a different year, so.
Yeah. Well, for the same questions, they should keep the same.
Yeah. So, state one. Although I think the other one, so it was about static before.
Yeah.
So.
But they have said it for dynamic, if I remember correctly.
Yeah. One disadvantage of programming of using dynamic data structure compared with static data structure.
It's.
Do not know the size that it requires.
Yeah, which
size
means
of data.
It's slower because it takes more time.
Harder to program as well.
Yeah.
More complex to program to write.
Hmm.
That is the only mark you'll get.
What the?
It's very strict.
But there's more than one reason why it's a disadvantage.
Well, that's what's these in thing.
This
Except
is what
more
I mean.
difficult.
This is what I mean. It's like luck of the draw.
Yeah.
You can have. There's like at least 3 different.
Keyword bingo.
There's at least 3 different disadvantages that I know of, and yeah, only that will get you the mark. So what? Anyway.
One type of data structure that which must be static.
Array.
Yes. Or saying that is a fixed length record. Ooh. Oh yes, it's this one.
I know it's what is this Lenovo solution? Oh, wait, that's mine. Sorry.
What?
I got a
Lenovo.
message from Lenovo, and I thought it was on your screen. So I was like, why hasn't he put it down yet? Because I got you on full screen, obviously, on Skype.
Ah. So draw a diagram to show the binary sort tree obtained. So alphabetical order.
Yep.
So in other words,
Good
order
old
given.
alphabet.
So
Yeah.
at the top it's going to be orange.
Yep. And then red is after orange, so it'll be to the right of it.
Yep. And then yellow is
Oh
god.
after red, so it'll be to the left of red. Right of red, sorry, right of red.
Yeah. So I was going to do abbreviations. So
Just do
Y.
L. Then what's next? Pink. Pink is before orange, after orange, so then it'll be to the left of red.
So O. No,
I've
pink.
got a
It's
little
pink.
slip which I got from Oxford, which has the alphabet on, so I just look at it.
Ah, good.
Green is before orange, so that
Yeah.
would be
So
to the
G.
left.
And then blue.
Blue would be to the left, G. Yeah.
Yeah, because that's at the start. I was thinking, where's the start of it? So yeah.
So is this a binary tree then?
Yeah, this is the binary tree.
Ah.
Then to get the order back up, you just go all the way down there.
Yeah.
Actually, let's do it in a different colour.
And then traversal.
Yeah, so this is post order traversal. So then your store B.
No, all of those are post order traversal. It's just for post order you do it straight right. For pre order it's straight left, and for in order it's straight down.
Yeah, so then your store B, store, which is your store G, wouldn't you?
Yeah.
Yeah.
No, think of it like this. Look, from B, draw a line straight right.
Do you want to draw the line?
Yeah, draw a line.
So from B to P.
Not the full length, but yeah, that direction.
So
Yeah, and then do the same for G. See, that's what you do. No, you have to do it from G, but anyway, that's what you do for post order traversal. So you do that for every single one, and then as you can see, when it's going around, it will intersect B first,
yeah.
and then G, and then P, and then Y, and then red, and then orange. And then for pre-order, you do it to the left. You do it straight left. So then if you're doing it straight left, you'll see that it will intersect orange first, then G, then B, then R, then P, and then Y.
Yeah,
Did you see that?
Yeah, I did this question at school, but
Yeah.
one of the people in my class, he added the words in the binary tree, but he did it in alphabetical order. So he did blue at the top, and he did it like that.
Yeah.
So,
yeah.
but you have to read the question, so in the order given.
Yeah.
So let's see if this is correct. Yes. What's the
Yep. 3 marks.
accept mirror image?
Which would mean, okay, so yeah. So if red was on the other side, basically.
Yeah.
Fair enough.
Award 1 mark for each for root, left subtree and right subtree.
Cool. Oh, lovely.
yeah.
Love these.
Yeah, I don't. And it's in.
So 2 easy marks straight away from this. Check to see if list is full.
Well, can you actually fill up a binary tree? I don't think.
Oh crap! Yeah, I was thinking a stack.
Yeah, I was about to say that as well. So any assumptions? So when you're adding, you're going to be, is new value more than the root? Yes or no? If it is more than, go to the right. If it is less than, go to the left.
Yeah.
It might be like that.
Oh, I've looked at the Markscheme. I would have got this one. It's start root. Then repeat. So it's like one of these, and then it's repeat, and then you have to say compare new data with current data, then follow left pointer, else right pointer, until pointer is null, right new data, stuff like that. 6 marks down.
Yes, and get up the Markscheme. So yeah, I keep forgetting to do the start at root.
Yeah.
Oh, was it when we did the question earlier, saying about starting at that location? Can't remember what question it was, but we did do something like that, and I forgot to say start at root. Bless
Yeah.
you.
Thank you.
I'm doing it from another location.
Oh, it's cross country bless.
Yes.
Let's go.
So you get marked for start at root, repeat until loop. So there you go. So you know when you're saying they do it in a piece of code,
Yeah.
when they say that's a piece of code, but then there's the simplified version.
Yeah.
Any assumption? Well, any additional guidance? Steps should be to a generic binary tree, not a specific example. Allow follow through from B if left and right are swapped. Oh, what's this? This type of data.
Oh, this is a stack. Oh, no, it's a queue. Sorry.
No, is it? There's a circular queue as well.
Oh yeah. This is a circular queue. No.
No, it's not. Is it? Is it?
Yeah, it is.
Oh, yeah, because the data. Yeah, the data goes there.
Yep.
So it is a Oh, they just wanted a queue, not a circular queue.
So it's first in, first out.
Yeah.
That's how you know.
Oh, complete the diagram.
Oh god, I'm gonna look.
Alright, what's it? Data item can be removed, so let's just do this. Are you drawing this as well?
Oh, definitely. Definitely.
And the good thing about streaming it is that we can look back on it later.
Yeah, so true. When we fail our exam in class. I'm joking.
Yeah, just have it tucked in. Just have contacts in and just have them projected, or have glasses.
Yeah.
There's glasses that you can have projected, or whatever.
Bring in some Google Glass.
So, is it your complete diagram removing one data? So A is removed. So I'm just going to put A in brackets. Then there's B, which is now front.
Yep.
So then there's C. Then there is the X and Y. And I've just realised I've done the X as you would if it's finally value of X.
Yeah. But it doesn't matter.
Yeah, and then there's the new space, which is going to be here, which is the free space. Then, of course, there's more things there.
Yeah. Look.
Is this what you've got as well? Or
Yeah.
so there we go. So A is now discarded. Front pointer moves to B. X is in cell of right of C, and Y is in cell to the right of X. The free pointer moves to the correct position, so it's after Y.
Yeah.
Oh, great. High level procedural language.
Oh, I love it. My favourite, obviously.
Okay, then describe the features of procedural. So high level languages include procedural and object oriented. So features of procedural high level language.
Oh, it's a lovely full marker. Describe the features.
Are you searching that?
It uses sequences, selection.
Are you reading that off somewhere?
Do you remember I told you about how I have
The Markscheme?
the one resource that has everything?
Ah.
I'm joking. I want you to. Okay.
You're only cheating on yourself.
Exactly. Oh gosh, you sound like an old man. What a cheating on yourself, dude. Okay. Procedural high-level language. Describe the features. Oh yeah, this one is the one that tells you how to do it, but not like it tells you what to do and how to do it, but not it doesn't describe it. If I remember correctly.
Let's have a look.
Ah, great.
Imperative language
Yep.
uses sequences, selection, and
Iteration.
iteration. Program states what to do and how to do it. Yeah,
So we've got 2
you've got that.
marks.
Program statements are in blocks. Each block is a procedure or function. Logic of program is given as a series of procedural calls. Yeah, so you've got 2 marks from that.
What did you get?
I got none.
You got 1 in spirit.
Yes. Oh, yay.
Sorry, yeah.
Can you remember the name of this class diagram? That isn't a question.
Communication.
Is it communication though?
Yeah. It was because we did it.
Oh,
And
yeah,
the only
yeah.
one we had any problem was activity. No,
No,
object,
this
sorry.
is a sequence diagram. Wow, I didn't even read it.
Oh yeah, it was sequence.
Yeah,
wasn't
wow,
it?
we
Yeah.
got that wrong again.
Yeah, sequence. Oh.
Yeah, it said it in the question, but still.
Oh.
The communication one, that
What
is...
is it? Oh yeah, it's the one with loads of arrows to the boxes. Oh god.
Yeah.
Okay, well we know what a message is. The message is what it's in brackets.
Yeah.
So that would be get button press, process key message, unlock.
So the
class
message... So the line would be like get button, so that is a message.
Yep.
Get button press.
Unlock as well. It's anything with a bracket.
Yeah, a class is like driver, key, and car.
Yep. Yeah. And a signal is lights, flashlights.
Yes.
Flashlights.
Another type of UML diagram included within this sequence diagram.
Activity. Object, sorry, object.
Oop, already done. There we go.
Object, I'll say.
Object diagram. Well done.
Well.
There. At the entrance...
Ah.
Oh, yeah, this is a communication diagram.
Yeah.
Remember the difference between two. Oh, we've got to complete it.
Is it a state diagram? What? Oh god, I need to look up. I had like UML up today, and I just could not be able to look at it. I even missed out on maths, and I was just like.
Let me just see if I can quickly copy
Just
that and
student
just
view
send
instead.
it to myself over here.
Oh my god.
If I can do that. Can I paste? Yes, I can.
Hmm.
And let's make that a bit bigger. Now it's drawn on top of it.
Yeah.
So now we've got to add the arrows to it.
Oh yeah.
So
3 marks.
the machine issues a ticket to the driver. So machine button issues the ticket, and we've got to label them as well.
Yeah.
So
Yeah,
button press, and press the button on the ticket machine. So button press. I'm just going to do it shorthand. Button press. Then that would be give ticket.
Yeah.
Then the next line that you'll need to draw, well, next arrow even. Oh yeah, we'll probably have to label them as well with numbers. So, and then just step 4 over here. So raise is the barrier, so signal would be raise barrier.
The next question's a lot of fun, don't go worry.
Let's see if this is correct. So yeah, that's communication diagram, what we said. Raise barrier. Yeah, raise barrier. I forgot to include the black brackets. And then, so the bracket, it looks like it has the, so T, that'll just be ticket, then B is barrier, P is press.
Yeah.
Ooh, what's that guidance? Give mark for arrows in correct direction, even if labels are incorrect.
Oh,
Give mark for labels if brackets are missing. Oh, so I would get it even. So if I missed out brackets, oh, that's good. That's nice and kind of them.
It's the one time they're generous. They show a
Yes.
hint of humanity.
Oh, we're more than halfway through, I think.
And now we've got a lovely UML diagram.
Oh, yes.
Such joy.
Let's change the colour to black. So what? A UML class diagram. So is this the one with the inheritance and that stuff? Yes or no?
The class. Yeah.
So is
Yeah.
this? It's like this one, yeah.
It's the one with the superclass and then the
Yeah.
subclass.
Let's undo that.
Inheritance. I mean, derived class. Sorry, derived.
Let's undo that as well. So where's it? So library staff. So I'm just gonna do it in shorthand. So lib staff. I just realised how big I've done that, but I can just scroll down a bit more. So library staff. So it has their names, contact, all staff workers at one library are paid annual salary. So would Anne's annual salary be added in the staff? Probably would, wouldn't it?
Sorry, I was distracted. Yeah, that looks pretty good so far.
Yeah, it looks horrible, but can you read it a bit?
Lib staff, name, contact, anniversary?
Annual salary.
Oh, annual salary. It's because you put an. Yeah.
That kind of looks a bit better, but
Yeah.
it's a small screen. That's my excuse.
No, that's fine.
So name, contact for each librarian. So lib. I'm just gonna
Remember, you need to add the dots.
Oh yeah.
To show that you can add more.
Yeah. Yeah, I'm just gonna do that.
Yeah, no one cares.
And zoom out a bit.
Cancel. Right.
Undo a bit more. So and actually let's use the eraser. I'm just using Office OneNote.
So this one should have one superclass and then 3 derived class. Theoretically.
Yeah, I think I need to include the operations as well into there.
Yeah.
Just leave a line for them.
Are there any operations?
There aren't any listed, but I'm just going to leave a space for them anyway.
Fair enough.
So there's the lib. I'm just going to call them lib just because shorthand.
Yeah.
Let's just scroll down.
Yeah.
And then each librarian has their qualifications, qualif. So dot. Yeah. Oh, good. So then underneath that they've got the senior librarian. So S lib. Let's do so S lib, and they've got so extra fee.
Oh, yeah, of course. Well, I would have probably put senior librarian on its own derived class. But yeah, that is correct.
Yeah, because you want it you probably want to limit the amount of data.
Yeah, because they qualify for librarian, don't they?
Yeah.
So I have all the qualities of the librarian.
Yeah, and then the cleaning staff you've got to include as well.
That would be separate. Yeah.
Clean. Yeah. Do not do the shorthand like I'm doing. I'm just doing this to save time a bit more.
Jeez, dude, that's actually pretty good. Secret
Clean.
choice. Such a good thing.
Each cleaner works on a certain days a week, so they need to be days. So days.
Yeah.
Is that all? Cleaning staff also work at the library. Yeah, I think that's it.
Dot, dot, dot.
Oh yeah.
Then have the extra tab for the
The operations.
operations. So what are the operations? Like, what would be operations?
Probably be like
Because I haven't done a lot of UML. I need to still do some more.
Well,
so I should be paying more attention to view, to be honest. Better.
One of these operations could be get username maybe, or something. Get.
Oh, okay. So it would be get like actual something, get information.
Yeah. So let's see if this is correct. Oh, new page. So, oh yeah, they want so ID, name, contact. They want more than that. Oh yeah, there you go. Get or set methods.
Oh, okay.
That would be a operation they would want.
We're probably going to lose 1 mark anyway.
Yeah, and I forgot. I just did their contact stuff, but I forgot to, and I did their name. I did their name. So so you can see lib staff.
Name.
Or the staff members.
Of course, you need ID. Yeah.
Yes, for easy identification.
Well, you still get
At
how many marks? Yeah, you see, you'd lose what 2 marks?
Yeah.
Because you forgot ID and you forgot get set method. It's 2 marks.
Yes.
Actually, wait, no, look up. Let's see how much we get.
Oh, I forgot to. I just put days. I didn't put days worked.
Yeah, but you'd put that into exam. So that's because you were abbreviating it. So you got 1, 2, 3, 4, 5, 6, 7.
Yeah.
7, 8, 8. You got 8.
Hmm.
You did. Because you got librarian as subclass, cleaner as subclass, senior librarian as subclass, at least 3 of the names, qualifications of librarian, days worked in cleaner only, inheritance symbols, and all 4 classes included. So you got 8.
Probably should have added a arrow here.
Yeah, well now you've got 8.
Yeah. Alright, so also the next question.
Well done.
Ooh.
Let's skip that. Whoa,
Discuss
2 8
the use-
markers in a row. That is rough. 2 8 markers in a row.
So discuss the use of functions and procedures. Let's just have a look at the answer.
Okay.
So, do you remember stepwise refinement?
Yeah, that's the breaking of a task into much smaller tasks to look at individually.
And it can allow easier access for.
And you can also
Like
have other people.
spread it out to a team more easily.
Yeah. And more easily program as well.
Yeah, so function block code, stepwise refinement, breaks a problem.
Intersections, yeah.
You didn't see the next answer to the question, did you?
No.
State the type of data structure which is used to handle procedure, calling, and parameter passing.
Oh, sure. Stack?
Yes. You bet you're not looking at the Markscheme, are you?
No. If you get a 1 marker and it says state the data structure, there's only 2 data structures.
Yeah, it's like
the
dynamic.
queue and the stack.
Oh yeah. What was I thinking of? Static and dynamic.
Yeah, but those are types of data structure.
Oh yeah, types.
They're not data structure. So it would either be, for data structure, there's 3 options. It would either be array, stack, or queue. So it's kind of like a guess. You want to make an educated guess, but I just guessed stack. Oh yeah, that was it. Okay, look. So it says, state the type of data structure which will be used in procedure calling and perimeter passing. But if you look through your notes, you'll never find anything about what perimeter passing is. But in 2014, there was a 5 marker.
Oh, so that's the thing that you're talking about then?
On explain perimeter passing.
Ah. Yeah, hopefully this year there isn't actually going to be any questions that's going to confuse us.
It's not even going to confuse you. It's not even on any notes. My teacher didn't even know it. You know?
Yes.
I bought an official revision book, and it was not on it. It was not in the revision
Was
book.
it the OCR one?
Yeah, it was the one by Alan Tall something. Cost me a tenner. Anyway, let's move on.
Yes.
So
Term parameter. Did you just say perimeter?
Oh, sorry. Yeah, sorry, parameter.
So parameter. That's the data part, isn't it?
Yeah.
The thing that can be manipulated by the procedures.
Yes, supply. Yeah, or functions. Yeah, and it's the information about a piece of data, isn't it?
Yes. Information about an item of data. So exactly what you said.
Oh yeah.
May be passed by
what
reference.
Coincidence?
You're looking at Markscheme.
Yeah.
Yeah. Oh, something we didn't include. Used as a local variable.
No, I was going to include it, but I thought maybe that's too much. I should try and.
Right, on the stack thing, it's got a CAO.
That's correct answer only.
Ah.
So that's you can't say anything else. Yeah, I know. I looked it up myself. It's correct answer only. Oh, good. Another table.
Yes. So.
Okay. So.
Uses mnemonics. That is the machine code.
Yeah.
Uses only binary or hexadecimal. Is that assembly?
Assembly language. No, assembly language uses mnemonics as well.
Does it?
Yeah.
Are you looking at Markscheme?
Okay, I'll stop.
You're cheating.
Okay, I'll stop.
So only uses.
I like how my method actually has been discovered now.
Yeah.
Just because I typed too loudly at one point.
That is just when you're looking at the Markscheme, you're just cheating on yourself.
No, because you're still learning.
It's a placebo.
Placebo. Yeah. No, because I'm gonna go through these all again. Anyway.
I'm gonna do the two papers that I've done today so far tomorrow.
Yeah. Jeez, but then aren't you gonna do some tomorrow as well, last year?
Yeah, but I mean, like, I'm gonna do the actual papers.
If you do 2 a day, you'll be done by Saturday.
That's the whole point.
Yeah, and then you'll have 3 days.
Oh, I still need to actually make my own one.
Oh yeah, and then you'll have 3 days to do that.
Yes. So explain how. We haven't finished this, have we?
Oh yeah, so mnemonics is assembly. That's all I knew. It was just assembly.
I thought it was within machine code as well.
No, it's just assembly. Because machine code is assemblies.
Yeah, machine code is that's only binary, isn't
Just
it?
remember this. Mnemonics. Oh, I can't even. Mnemonic is was used with low-level language, wasn't it?
Yeah.
Assembly language is low-level language. Machine code isn't. Machine code's mid-level language / high level, I think. So yeah. So anyway, it's a machine language. Anyway, I mean it's assembly.
Alright, let's have a look at what uses mnemonics. No, this is just going to show mnemonics.
I've seen it though. I know the answer. See?
Oh.
No!
Yeah, just only binary, so yeah, that is definitely machine code. May use relative addressing.
High level, I'd say.
Yeah, because it's addressing, yeah, I guess so. No, assembly. Oh. May use local variables. That's high level. And assembly?
Machine code? No, assembly is low, so it wouldn't have access. Would it be machine code?
In machine code low though as well.
Okay, yeah, so just high level then.
Yeah, just high level. Yep, just high level. May be translated in.
Oh, that's machine code.
Wait, we just skipped past one. Needs translation before the program can be executed. That
machine.
High level. That needs to be
machine has to be translated into object code. Machine has to be translated into source code, which is then translated into object code, isn't it?
Thought you can just run machine code straight away. Well,
Okay, I'm going to say
but,
machine code. You're going to say high-level language. Let's do it.
oh, high level and assembly.
God damn it, as well.
So that's one of the two ones.
Yeah, yeah.
Maybe
Yes,
translated into intermediate code.
assembly language, it has to be
Yes, because
translated.
it uses the assembler. No, high level.
Yeah.
Oh, we got that wrong. Immediate addressing. It uses the index registers. That's all I know for it.
Yeah.
You gonna add anything else?
I don't have
Without looking at the marks.
I don't have my mark scheme now. I don't know anything. Um, immediate addressing. It's done immediately. I'm joking. I don't know anything about immediate addressing. So.
I think it like sync address is the address is used to read the data directly. Maybe I don't know. Used in assembly language, uses data in address field as a constant. Oh, that's what I wanted.
Oh, well. Yeah, because it's two markers.
Explain how and why the index register is used. It
That's
is
a
used.
special register from the von Neumann.
I would say it's used for intermediate.
Okay, yeah, same.
Intermediate indexed.
Yep.
Coincidence.
Create an index which you can search.
Yes. Used in indexed addressing.
Oh, god damn it, of course.
Well, we got that wrong. Stores a number used to modify an address, which is given in an instruction.
Yeah.
Allows efficient access to a range of memory locations. For an example, you could have given used to access an array. So when it's explained, you might as well give an example just to be safe.
Yeah, yeah.
Any no additional stuff.
I wonder what it said for the table.
For the table, accept any answer that says that local variable can be both in assembly and language and high level, and the relative addressing is used in machine code.
Oh, fair enough.
And it's a 1 mark per correct row. And it's it's a 6 marker. It was
Yeah.
a 6 marker.
Yeah. I can lose 15 marks if I want to get this stuff.
Oh yes, let's do an entity
Oh,
relationship.
this is easy. Cool.
Right, so
Hopefully we get something like this for our exam.
yeah, so I'm just gonna do A here.
Yeah.
So A to B is a 1-to-1.
Yep.
B to C is a 1-to-many.
Yep.
Now A to D is a many to one. So it is a many.
Oh, you do it all on the same diagram, of course.
Yeah, because it's the same thing. So
So I probably would have done a different one, so I'm glad that
yeah, something you've got to watch out for. Many is for A, and 1 is for D.
Yeah.
Because I accidentally did it the other way around, so I added D in the correct place, but I did the many D to 1A.
There's only one day, yeah.
It.
1 day.
Yeah. Yep. So there you go.
Yeah, we're done.
No additional entities or relationships on all one diagram with boxes.
Yeah.
State the meaning of the term primary
Oh, I know
key.
this.
Go on then.
Unique identifier.
Yes, and you didn't cheat, did you?
Hopefully not.
There you go. And you could have said in a table, but that's just...
Yeah. It's not needed.
How many questions? Only a couple. So explain why a foreign key is also a primary key, but a primary key need not be a foreign key.
Because a foreign key has all the attributes of a primary key. However, a primary key does not need all the attributes of a foreign key. Well, crap, it's 4 marks. How do I phrase it?
Probably say a foreign key calls a primary key or links to a primary key.
Yeah, because it has all its attributes.
Yeah.
So think of a primary key as a superclass, then a foreign key is a derived class. Basically.
let's have a look at the answers.
No, we
Foreign,
can do it.
foreign keys link the tables,
Yeah.
so that only one record is accessed.
Oh yeah,
An
of course it's
example, primary key from
data
B.
inconsistency and data
Use
duplication.
Yeah, so you're using an example from the actual diagram. So from B is used as the foreign key in C.
Oh geez, wow. See, look, if this was a question, because it's B, I would have completely forgot that A could link to it.
Yeah, so it's using an example from that. From
Yeah.
Oh, SQL.
Such fun. An attribute. An attribute
It,
is
so
stock
name
info,
Yeah, so stock info or
quality or price, quantity or
yeah, so
price.
stock number.
Oh yeah, sorry, stock
You
number.
said stock info.
Yeah, I said it twice actually. Stock info. Silly me.
And one table is the stock.
Yep.
So let's see, so stock number, stock. The purpose of this code.
Oh, how do they phrase this? Okay, so you'd say, well, it's to get the information on the stock, where then you check to see if the quantity of the stock is less than 100. If it is, give the price description. But
No, give the price, and it is so order by price, and the
yeah.
DCE is
Oh
descending
yeah,
order.
yeah. Oh, I didn't know that.
So list values of attributes for all stock with quantity less than 100 remaining, in order of price from highest to lowest.
Okay, so that's how they structured it. So the first mark you always get for just saying list of attributes, and then the second you say from doing the inequality, and then the last is just saying the
order.
price. It's fair enough. Okay.
Yeah, so it's so 3 marks.
Well, we only have one page left.
Is it?
We
Yep.
would have been like doing this for now.
We've actually been doing this. How long has the call been going for? Well, an hour, 10
An hour
minutes.
and 10 minutes.
And the stream's been going for an hour, 13 minutes. Well, my recording of it as, and the main stream's been going for an hour, 12 minutes.
Fair enough. It's 2 minutes difference.
Yeah. Oh, explain the difference between char and varchar.
Okay.
I know this. Do you know it?
Yep.
Are you not looking at the Markscheme?
I'm not doing that anymore. Okay, do you want to do it then, or should I say it? Because you know it.
So I'm not. So
test myself?
you can see what I'm looking at. If I isn't sure you can see. So char is a fixed length, but varchar is a variable length.
Yep. Hold on.
So let's see. Yeah, char is fixed length, varchar is variable length.
Yeah.
I used this example in the video.
Okay, explains lines 5 and 6. Department ID, char 5. Primary key, staff ID. Oh, 5 and 7, sorry.
Yeah, 5 and 7, yeah. So
foreign key, department ID, references, department.
foreign key is the department ID, which is within the department data table.
Yeah.
Probably say that. Do you agree?
Yeah.
Do you agree to disagree?
I just agree with your amazing wisdom. Well, it's a foreign key, which means it's linked to line 6.
Yeah.
Oh, okay, so we know that line 5 is setting the department ID to a fixed variable, to a fixed length, sorry, of 5, because it's char.
Yeah.
So it's setting it to a fixed length of 5. And then line 7 is setting the department ID to the references? Yes?
Let's have a look.
Let's have a look.
Let's have a look.
Let's have a look.
Line 5 defines department ID as an attribute of employee. So that is within that create table. Line 7 defines department ID as the same attribute in the department table, where it is a primary key.
So basically, use the lingo, use the tech
to link the tables.
Use the tech lingo of attributes.
Yeah, no additional guidance.
Okay. Give 2 reasons why views of data are made available to users of the database.
Ooh. 2 reasons why views of data.
Yeah.
I've completely forgotten what that means.
That's like people's access to it, isn't it?
Oh, so it'd be no, I'm thinking of something else. The a database management thing. Wait, is this database management, isn't it?
Yeah. It'll be like to
Uh,
protect data or
yes,
security.
to prevent unauthorized access.
Yeah.
To allow the user with limited expertise or something like that.
Yeah.
Let's see. So users can access the data they need. Users do not need specialized knowledge. To protect data to prevent unauthorized access.
Yeah.
We went through this one quite quickly.
Yeah, we really did.
Yeah.
Though these papers, they never do take you the full time.
No. And wait, was there any question on? There was one question on binary tree, but you didn't have to traverse it. You had to make your own binary tree.
Yeah. With the orange and yeah.
Are you available tomorrow at 4 again, or
Yeah, sure.
what one do we need? What one are we gonna do?
Tomorrow is Thursday. I have double free at the end. Yeah, I'll be home early, so definitely, yeah.
Yes, we're June 2011, and then so from 7 to 9 we do the January 2012.
Okay, and then on Friday we'll be
Yeah,
doing next two.
yeah, that one.
And then we'll be done on Saturday. Ah, that's cool. Yeah, that sounds good.
Ooh, that's not how you spell Friday.
Do you want to stop the stream or are we going to continue?
Yeah, I'll stop the stream. Thanks for watching this video.